All right, what's up, team? Coming back here. So the next topic is going to be on formal chart. Again, just like in Gen Chem 1, it's just review. Okay. All right, the formal chart tell you the charge of each atom in the molecule. Right, so it's different when atom it's just by itself as an atom, but an atom in the molecule is totally different. The formal charge tell you the charge in the molecule. Okay. All right, so this. If you look at in the textbook, in Gen Chem textbook, or in anywhere, there's a quite long equation to calculate formal charge. Okay, but I'm going to keep things simple. The formal charge equal to valence electrons minus dots minus lies. Well, you'd be like, hey, Pete, what do you mean by that? Well, I'm going to tell you right here. All right, let's calculate the formal charges of this oxygen in the three molecules. Okay, start with this guy right here. So formal charge, valence electron minus dots minus line. Look at this oxygen right here. Okay, so valence electron of this oxygen is 6. All right, group 6 valence electron. How many dots are there? Like the lone pair. 1, 2, 3, 4. I mean electrons. So 1, 2, 3, 4. There's 4 dots. So minus 4. How many lines are on it? 2 lines, right? So the 2 bonds, minus 2, that's 0. Okay, we're gonna keep things simple here. So formal charge, valence electron, minus dots, minus lines. All right, start with the oxygen on the right side. This guy right here. All right, start valence electron 6. How many dots? 1, 2, 3, 4, 5, 6. 6. How many line? 1 line. So 1 there, equal to negative 1. Okay, lastly, so oxygen right here. So valence electron 6. How many dots? 2 dots. How many lines? 3 lines. Total of plus 1. All right, I keep things simple there. If you see later, all right, if you become more familiar with all this molecule, you realize that a regular oxygen and neutral oxygen have 2 bonds, and this guy's neutral. Right, 2 bonded oxygen is neutral. If somehow oxygen have 3 bonds, adding another proton on it, this guy actually have plus 1 charge. All right. If we remove this hydrogen, this 2 electrons, and this bond become lone pair. So oxygen with 1 bond, only 1 bond, that's a negative 1. All right. So I don't want you to memorize or flashcard this. All right, this one just treat it like a functional group, treat it like a kitchen tool. You see them often enough, you know it. Oxygen, normal oxygen, 2 bond, neutral, 3 bond, positive 1, 1 bond, negative 1. Okay, I want you to be able to recognize this guy just like a functional group. All right, keep going further. So try this one. So nitrogen. All right, just look at the nitrogen. Start with this guy. What's a formal charge? Start with valence electron. So 5. How many dots? 2 dots. How many lines? 3 lines. Total of 0. Good. This is nitrogen with 3 bonds is neutral. All right, that's a regular nitrogen. All right, now nitrogen with 4 bonds. Adding any bond, usually plus 1. We'll see. All right, valence electron 5. How many dots? No dot, 0. How many lines? 4 lines. Total of plus 1. Look at that. Okay. If we remove number of bonds, so from 3 go back to 2, that's going to be a negative 1. Now let's see if it's actually negative. So valence electron 5. How many dots? 1, 2, 3, 4. How many lines? 1 and 2. Negative 1 right there. Right. Just like oxygen, you add bond, you plus 1. Remove bond, you negative. Go negative. Okay. All right, now come down here. So let's try carbon. All right, same thing. Regular carbon have 4 bonds. That should be neutral. Now take a look, neutral or not. Valence electron 4. How many dots? No dots. How many lines? 4 lines. Total of 0. Okay. All right, we're gonna go this guy. So from 4 bond to 3 bond. What do you think? From 3 bond. Let's try it out. Check it out. So valence electron 4. How many dots? No dots. How many lines? 3 lines. Total of plus 1. Good, it's plus 1. All right, carbon, this guy right here. So 3 bond but 2 electrons. Okay, let's see. Valence electron 4. How many dots? 0. 2 dots. 2, 1, 2 right there. How many lines? 3 lines. Total of negative 1. This side's negative. Okay, carbon with the positive charge has a name we call carbocation, not carbocation. It's carbocation. Carbon with a negative charge we call carbanion, or it's carbon and anion, basically carbanion. All right. Okay. All right, let's try this one. So identify formal charges in acetylcholine. So we have to look at all the atoms and identify who has formal charges. Okay. Try on your own. Pause the video and let's check with me. right? Start with the hydrogen. Can you see that all hydrogen 1, 2, 3, 4, 5, 6, 7, and then the 9 right here, so 16 total. They are the same thing. Hydrogen with 1 bond. All right. Should this is regular hydrogen? The formal charge should be 0. But let's calculate real quick. All right, hydrogen. So group 1, no dots, minus 1 line, total of 0. Okay, so all hydrogens here have 0 formal charge. All right. Next one, we're going to go to carbon. So all of them have 4 bonds. So that's regular carbon, 0 again. Right. But let's calculate it. So carbon group 4. All right. No dots. None of them have dots. No electrons. How many lines? So 4 lines, 4 bonds. So total of 0. That's going to be 0. No, that's plus 1. That's wrong. Right. That should be 0. Okay. So all carbon here have 0 formal charges. All right. Go to oxygen, right? This is a regular oxygen, 2 bond oxygen, so 0 as well. But let's calculate it. So group 6, right? How many dots? So all of them have 4 electrons, yeah? So minus 4, and all of them have 2 bonds, yeah? Negative 2, 0. Regular oxygen, 2 bonded oxygen, 0. All right. Last one, go to nitrogen. So this nitrogen have 3 bonds. If you still remember, a regular nitrogen, if you leave a symbol, 3 bonds, right? This one have 4 bonds. This is going to be plus 1. Let's see, calculate it. So nitrogen group 5, no dots, 4 lines. So line plus 1 there. Okay. All right. So watch out. So carbon is 0, not plus 1, right? That's typo. Okay. All right. Let's go to. All right, next one. I would like to add a little bit more functional group there, so make you familiar with it. All right, so we have C double bond O and O. Okay, this one we call an ester. Right, usually used in perfumes or food senses. So if you see, like, if you smell something like a fruity, flowery, usually then ester. Okay, let's say the first compound. So C double bond O, we have carbon chain. So C double bond O and O, between the carbon chain basically. The methyl butanoate. This guy smells like pineapple. We have another one. This one ethyl. This is methyl. This is ethyl butanoate. This one smells like mint, minty smell. Okay. All right. So we have C double bond O between the chain. Now C double bond O at the end of the chain. I'll take a look. So we call it carboxylic acid. It's the only functional group that have acid properties. C double bond OH. Okay, that's a functional group. Formic acid, formica in Greek means ant, so this is I don't know what's it called, like the ant, the formic acid. They can choose formic acid to protect itself. All right, acetic acid or vinegar. So see the double bond O H. All right there. That's also carboxylic acid. Okay. All right. So carboxylic acid is the only functional group that have acidic property. Now we go to the functional group that have a basic property we call amine. You probably have heard amino before. Okay, that's an amine group or amino group, NH2, with a carbon chain, long carbon chain there. Okay, so amine is only basic functional group. The small amines smell like rotten fish. So we have methylamine, we have ethylamine, right? So carbon chain, nitrogen, carbon chain, and nitrogen. All right. Amine is also found in medicine like morphine. So we have nitrogen there. If you see a nitrogen, that's basically an amine, right? In between a chain, at the end of the chain, doesn't matter. Nitrogen, that's an amine. If you watch Breaking Bad, so methamphetamine, so meth, that's also a type of amine. Okay, we have a primary amine, we have a tertiary amine, we have secondary amine. We'll talk about that later. Okay. Now look at this 3 compounds right here. So if you want to see the amino group, amine group, that we have carboxylic acid C double bond OH right here. All of them have the same thing. This glutamic acid. We have cysteine, NH2, and COOH. So this is also carboxylic acid. Glycine, same thing there. We call this amino acid because the molecule has both amino group and carboxylic acid in the same molecule. Okay, we call amino acid there. All right. Now, going further, so amide is a product of carboxylic acid and amine. It's a backbone of protein. You see this abundant in pretty much everything in our body. Okay. All right. So amide also found in some type of medicine. For example, lidocaine, pain relief right here, or an anesthetic drug. Okay. Not anesthetic drug. No, it's not. What's it called? Crap. I forgot. Yeah, anesthetic medicine. Yep, you're right. No, I'm right. Never mind. So lidocaine, you have heard procaine, those stuff. Okay, so they have a C double bond O and H in it. Okay. Now I want you to take a look right here. So if I combine these three amino acids together, C double bond O H, and we have amine, fuse them together, you actually get an amide. Okay, we call peptide bond as a protein. All right, so those are all amide. All right. All right, let's see functional group. What we got so far? We have alkane, alkene, and alkyne. Single bond, double bond, triple bond. Alkyl halide, so basically hydrocarbon with the halogen in it. All right. We have an OH, that's an alcohol. Oxygen within the molecule, that's an ether. C double bond OH, that's an aldehyde. C double bond O in the middle of the molecule, right? That's what we call ketone. Carboxylic acid, C double bond OH, that's the show acidic property. There's only a functional group that have acidic property. C double bond OO, that's an ester, right? Add two more, so we have a basic functional group we call amine. And we have amide, which is a product of carboxylic acid and amine. You got see them half carboxylic acid, half amine right there. And the last one, you probably have seen benzene ring, look something like that. Maybe naphthalene, two benzene ring fused together. We call it arene. Okay, that's the name of the functional group. We call have aromatic system. Look like that. Okay. All right. So this is a class activity. Right. So what you have to do, you're gonna let's write it down or print it out, whatever you want to do. All I want you to do is complete it, take a picture, scan, and then upload it on Blackboard. I'll send an email, okay, where to upload like all this class activity. For chapter 1, they are, I don't remember. There are several of them, so find them, hunt them down, and do them all. Right. So class activity 1, they are 1, 2, 3 questions. I give some of them. I give you an answer. Okay. So complete it and upload it onto Blackboard, and that's it. Okay. All right. Let's move on to the next video.